calculated by the different weights. So out of that, we have discussed two criteria. In the first criteria, the load carrying capacity of an individual pile is calculated. Then, by the first criteria, we will just calculate the load carrying capacity of an individual pile, multiply it by the number of pile. So this is the first capacity. Then in the second one, we will consider the whole group. Suppose this is the whole group, and these are the 9 piles which are surrounded by the soil. Then the whole group is act as a single member, and there the load carrying capacity is calculated by the second criteria, where instead of a single small column or small pile, we will consider a group of pile is a single pair of dimension b by b. So what is b? B is the half the diameter, and then the center to center distance between the piles. So it will be 2s plus b. So that is b, and which is extended up to a depth of b, up to a depth of L. So here we will just calculate the load carrying capacity by the another criteria, where the cross sectional area at the tip of the pile is considered as a b square, and the perimeter of the group is considered as 4b. So that is the only change. Out of these two, both the values should be same. Both the values should be same. In that case, that we can say that there is an optimum spacing, where the load carrying capacity of pile by both the criteria is same. In that case, we will say that the spacing is optimum, where the efficiency of the group is 100%. Right? If suppose the spacing between the piles is increased, in that case your B is increased, and naturally the load carrying capacity may increase because B is increasing. Further, if suppose we will reduce the S, B is reduced and therefore the load carrying capacity is reduced. But we want the optimum spacing at which the load carrying capacity by both the criteria should be same, and that spacing is called as the optimum spacing, where the efficiency is 100%. So today we will discuss the numerical based on it. Numericals based on it. Now first we will take a simple numerical where a single pile is installed in a clay soil, right? So first, the given data where diameter of pile (30 centimeter). This is this point 3 meters. This is the data which is given. Then the length of the pile is length of pile 9 meters. Then, as the pile is inserted in a clay soil, there is a clay soil is available. Of different properties are given. The first and the very important is cohesion, that is the 100 cohesion, which is taken as 40 kilonewton per meter square, and alpha is taken as 0.7. Then the factor of safety value is given as 2.5. So in this case, you have to find out the load carrying capacity, that is ultimate capacity of pile, that is Q, U, and this another one, you have to find out the allowable capacity. allowable capacity of pile, and that is Q allowable. So these things are given to you. Now, as the soil is installed in a clay soil, as the soil is installed in a clay soil, so naturally the bearing capacity can be calculated based on the frictional resistance. So here I will just consider this is the pile which is being installed in a soil of properties C, Cu, and assuming that this soil is extended up to a large depth, nothing is mentioned where there is a layered soil or the soil below the base of the footing is different. So in that case, whatever is the underlying equation, same value may be considered over here. Right? Now here, as nothing is mentioned whether the soil, whether the foundation is rested over the hard strata or anything else, so we will consider both the resistance in this case. That is the tip resistance and the frictional resistance. So here, this is QP and another one is QS. Another one is QS. So what is QU? QU is equal to QP plus QS. Now, the soil is a pure cohesive soil. Soil is cohesive soil, and therefore the value of phi is equal to 0. If the value of phi is equal to 0 in pile foundation, we are taking LC value is 9. So here this LC is 9 and N gamma is 0. So here this value is for D foundation or this is for the pile foundation. This NC is 9 for the pile foundation. So what is the equation? The equation is QU is equal to C NC, because the surcharge term we are going to neglect, because no surcharge we are assuming that is neglected, and the third component, that is the bearing capacity of soil, of foundation soil, that is considered as 0 as N gamma is 0, right? Therefore, this is C and C, and this C and C is acting at the top, at the tip of the pile. So here we will consider the area, that is pi by 4 d square, plus another one is QS. So here this QS is C into alpha. This is C into alpha into pi dl. So this component is QP and this component is QS, right? And this we will consider as QS A, QP, AP, QS, AX, right? So here this is QS and this is AX. Here this is QP and AP. I think this is clear to you all, because we have already discussed this in the previous lecture also, right? So in this case, this QU is obtained to be 289 289.2 kilonewton. Then how will you get the value of Q reliable? So in this case, this value is obtained to be like this, whereas Q reliable is equal to QU divided by factor of safety. Q reliable is equal to QU divided by factor of safety. Now, as the factor of safety value is given as 2.5 and it is 289.2, so here we will just calculate 289.2 divided by 2.5, and lastly it is found to be 115.7 kilonewton. So by this way we can solve the numerical. It is a very simple numerical which is asked for the single pile. Now, in the examination, the problem is not like this. Here you have to consider the group of the pile. That group of of the pile may be placed in a square pattern, it may be in a circular pattern, it may be in a rectangular pattern, right? So the next numerical in which we will consider the 9 piles which are installed in a group of a square pattern. So second, example number 2. Example number 2, where the data is given as pile length of pile is equal to 10 meters. Length of pile L is equal to 10 meters. Then diameter of pile is taken as 0.4 meter. Then cohesion, that is CU, undrained cohesion, which is taken as 80 kilonewton per meter square. Then alpha is the adhesion factor. Alpha is equal to alpha is equal to 0.8. Alpha is equal to 0.8. Now here also the load carrying capacity of the pile you have to determine. In this case, in the another one, we will consider this is 0.3 meter, 10 meter length. Then CU is taken as 100 and alpha is taken as 0.6. Then here, factor of safety is taken as 3. Factor of safety is taken as 3 and the 9 piles which are arranged in a square pattern is given. 9 piles which are arranged in a square pattern. So here 9 piles arranged in square pattern. Now, one of the very important thing which is not mentioned over here. One of the very important thing which is not mentioned here, just to determine the value of B, that is the dimension of the weir, we need or we will require a spacing. So in this case, first spacing is not mentioned, but we know that the optimum spacing is varying between 2.5 to 3.5 D. So we'll just assume spacing between the pile is 2.5 times D. We are assuming that it is 2.5 times D. As it is 2.5 times D, so what is D? D is given as 0.3. So spacing is 75 centimeter or 0.75 meters. So this is the assumed spacing. Now here what we will do, we are just calculating the load carrying capacity of a pile group. So here we will just take it into consideration. This is the group of the 9 pile. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So all these piles Here, this is the group of the pile. Here, this is pile tag. And these are the piles which are inserted into a these are inserted into a hard strip, right? So spacing is, how do we get the spacing? Spacing is 75 mm or 75 centimeter. 0.75. Here it is 0.75, right? So what is B then? B is equal to B by 2 plus S plus S plus B by 2. So it is B is equal to 2S plus B. So what is S? S is 0.75. 2 times S means 1.75 plus diameter is 0.3. This it is assumed to be 1.8. So there is a spacing between the pile. It is 75 and the B is calculated as 1.8 meters. Now we will calculate the load carrying capacity by the first criteria. So first criteria. In this case, we will first find out the value of Q ultimate for individual pile. Individual pile. So again, the piles are inserted in a clay. Piles are inserted in a clay. Therefore, the equation is CNC into pi by 4 d square plus C into alpha into pi d L. CNC into pi d square, that is the area at the tip of the pile. Alpha is the adhesion factor. C is the cohesion which is available over here, and pi d L is the perimeter over the shaft length it is being existing. So here it is being calculated as 100 into 9 into pi by 4 0.3 square plus C is again same. Nothing is mentioned here. The soil below the pile is different and pile in the pile length is different. The soil is assumed to be homogeneous because only one cohesion is given, and therefore here this CS is equal to CP. And here again the same value we will take it into consideration. 100 into alpha is 0.6 into pi into 0.3 into 10. So by this way, we will get the value of QU individual. QU individual. Now, as the QU individual is found to be it is found to be 630, 628.8 kg. So this is the load carrying capacity for an individual pile. Now we will calculate it for QU group, and it is QU individual multiplied by number of piles. So here this QU group is found to be QU group is found to be 5659.2 kilonewton, and this is the value which is obtained by the first criteria. This is the value which is obtained by the first criteria. Now we will discuss the second criteria. Here we will consider the whole group as a single member. The whole group as a single member of dimensions d by d. So instead of pi by 4d square, we have to write a d square, that d is the dimension of this which is found to be 1.8. And just to determine the perimeter, here we will take 40 into L. So here, QU group is equal to 100 into 9 into B square into B square. What is B? B is 1.8. So it is because what we are assuming? We are assuming that the whole group is completely a square group and the load, that is the tip resistance, is acting at the bottom and the area at the bottom of the pi group is B square. Therefore, we will consider here B square then into 100. And when we are talking about the group, this whole group is considered to be the single member or the single pi of dimension d by d. And in such cases, we will never consider alpha. Alpha is here, it is taken as 1. Alpha, when we are considering the group of the pi, alpha, that is the adhesion factor, is taken as 1, and therefore it will be 100 into 1 into 4, 1.8 into 10, 4L, 4B into L. 4B means the perimeter that we will consider, and the square, the perimeter of the square is 4BL, right? So here we will calculate another group capacity, that is 2U group. It is found to be it is found to be 7236. It is found to be 7236 kJ. So this is the load carrying capacity by the second one. So this is criteria. Now there are two values which we have obtained. Now which value will be taken into consideration out of these two? Minimum value out of these two will be taken for the load carrying capacity of the group. So here minimum of about 2, minimum of about 2 is considered for further calculation. Therefore, minimum is this value. This is assumed to be minimum value. Therefore, for Q allowable, QU or Q allowable for group is taken as QU minimum divided by factor of safety. And here the minimum is 5659. Therefore, the factor of safety is applicable for the first one, and it is found to be 1886.4. So these type of answers may be asked in the examination. Many times it may be mentioned that find the load carrying capacity for an equal spacing or an optimum spacing. Find the load carrying capacity for the optimum spacing. In that case, you have to find out the S equation in terms of S, and then you just have to equate these two values. The value which is calculated by the first and the value which is calculated by the second group. When we will equate these two values, it shows that the group efficiency is 100%. And then you have to find out the optimum spacing. Right? So this is the next type of numerical. I think this is okay for you. So the next part, we will just consider where the tip resistance is taken as 0. Sometimes in some of the numerical. Now in this numerical, we have taken both the frictional resistance as well as tip resistance. But in some of the numericals, it is mentioned that neglect end bearing resistance. Neglect end bearing resistance. In that case, we have to take the QP0. Now here, there is a group of 16 pipes. Given data, in example number 3, given data is number of pipes, are 16 pipes. If it is 16 pipes, means these are inserted in a group of square pattern into 4 by 4 matrix. 4 by 4. Then the diameter of the pipe is 600 mm. Then here the spacing is given. Spacing is given, and that spacing is found to be 1.2 meters. 1.2 meters. Where the cohesion is equal to 30 kilonewton per meter square. Adhesion factor is 0.6. And the very important thing is mentioned over here. Length of the pipe is 6 meter again. 10 meter of pipe is equal to 10 meter. Now in this case, it is clearly mentioned that neglect end bearing resistance. It is clearly mentioned that neglect end bearing resistance. Just you remember, these are the some of the hints are given into the numerical. It means that you have to consider QP value is 0. Neglect end bearing resistance. Where QP value we have to take as 0. Just always remember that here the QP value we have to take as 0, and the pipes are then become a friction pipe. Assume the pipe is a friction pipe. What is the friction pipe? In this case, all the load is taken by the pipe, and the friction is developed over the periphery due to the surrounding soil. And there, the frictional resistance is taken into consideration. Here, in this case, we are assuming that the pipe is of group 60, and there are 4 pipes which are arranged in a square pattern. So here, there are 16 pipes which are arranged in a square pattern, and it is assumed that the value of QP is 0. QP is 0. Means whatever load is taken by the frictional resistance which is developed over here, and this is QS, here also this is QS. Right? So what is the equation? QU is equal to QP plus QS. Here, this is 0. In that case, whatever QU, that will be due to QS only. Right? QU, whatever ultimate load, is taken by the frictional resistance only. So first we will calculate the first criteria. In the first criteria, QU of an individual is equal to CNC will not be there because we have considered QP is equal to 0, and therefore it is C into alpha into pi d h. This C into alpha into pi d h. What is C? C is 30 into alpha is 0.6 into pi, then 0.6 into 10. So this is the load carrying capacity of an individual pile. Now we will find out the QU for group. QU for group is equal to QU for individual multiplied by number of piles. Multiplied by number of piles. And here this is 339.2. 339.2 multiplied by 16. Therefore, QU for group is equal to 5428.7. 5428.7 kilojoules. So this is the load carrying capacity of the pile by the first criteria. In the second criteria, we are considering that whole as a group, and therefore here this is criteria 1, this is criteria 2. In this case, now the QU group is equal to alpha is not there because when we are considering the group, alpha is taken as unity, and therefore 30 into 1 into what is the perimeter? Perimeter we have to find out first to the B. Now what is B? B is the spacing between the pile S. Here also S, and here also there is a S plus D by 2. Here again it will be D by 2. So B is equal to, what is the value of B there? B is equal to 3 times S plus D, and the spacing is 1.2 and the diameter is 600. So it is 3.3 into 1.2 plus 0.6. 3.6 means it is 4.2. So here it is found to be 4.2 meters. Now the perimeter is 31 into 4.2. 4 into 4.2 into length of the pile is 10 meters. So the value of QU of group is equal to 3024 3024.5 kilograms. So this is the value which is obtained by the second criteria. Now out of these, which value will be taken for the further consideration? Minimum of these two. Here we will consider this value just to determine the value of Q reliable. So Q reliable is equal to QU for group divided by factor of safety. Divided by factor of safety will give to the value, and that is the 3024 is the value divided by the factor of safety, which is given as, we have to just find out the load carrying capacity of an individual pile, but here you have to neglect the end bearing resistance. Sometimes in the same numerical you have to find out the group efficiency. Just remember, sometimes in the same numerical you have to find out the group efficiency. In that case, what is group efficiency? I will just write it over here. Which is denoted by beta, where it is QU for group by the second criteria. U for group by the second criteria divided by QU for individual multiplied by number of piles. This is the group capacity by the first criteria and multiplied by 100. So in this case, the value is 3024.5 divided by 5428.7 multiplied by 2. So in this case, from the observation, you can say that this efficiency is less than 100%. Less than 100% means here you have a scope to increase the spacing. Further, you have the scope to increase the spacing. When the spacing is increased, this load carrying capacity may increase, and sometimes if you have to find out the optimum spacing, in that case, we will just equate these two values and calculate the spacing. Right? So this is the another type of numerical. So these are the very simple numericals. These are the very simple numericals. The numerical may be like this only. Here, sometime everything is given to you. Everything is given to you. You have to find out the spacing if the efficiency is 100%. Like that, the numerical may be asked. Sometime the another things are given, such as there are the layered soil deposit. If suppose there are layered soil deposit, in that case we have to take the frictional resistance twice for the different length, whereas just to determine the friction at the bottom, we have to take the Now, in the next example, we will see there are the layered soil deposit. In the next example, we will see there is a layered soil deposit. Layered soil deposits where 12 piles are arranged in a rectangular piles. 12 piles arranged in a rectangular pile. Where piles are arranged in a rectangular pile, where the diameter is given as D is given as 300 mm and L is given as 10 mm. L is given as 10 mm. Then so here this is given as this is another numerical. These are given in the rectangular pattern. 12 piles arranged in rectangular pattern. I just wanted to show you whether what is the effect of the pattern on it. Then C is given as 40 kilonewton per meter square. and spacing is taken as 1.2. Spacing is taken as 1.2 meters. Then the factor of safety and average factor. Average factor alpha is taken as 0.5 and factor of safety is of 2.5. So this is the data which is given. Now here what is the change? Change is that the piles are arranged in a square pattern. Instead of square pattern, these are the piles which are arranged in a rectangular pattern. So here the number of piles are 12. Number of piles are 12. So we are assuming that there are 3 rows of pile 4. So here 1, 2, 3 and 4. Then 1, 2, 3 and 4. 1, 2, 3 and 4. So this is the pile row. There are 3 rows and in each row there are 4 piles. So here, what is the change in this now? You have to find out the L and B in this case. So what is this? It will be L. Minimum dimensions we are considering as B and the major is L. So this is B, or you can write just taking the area, you have to change the things. So what is L? L is equal to 1. There are S, S and S. So here L is equal to D by 2 plus S plus S plus S plus D by 2. So it will be 3S plus D, 3S plus D, whatever is the value of L, just take this. And what is B then? B is 2 spaces, that is 2S plus D. When we will calculate the area, we will calculate the load carrying capacity by the second criteria. Now remember, when we are considering the second criteria, the first criteria remains same. In the second criteria, what changes we have to make? We just calculate QU is equal to C and C. And what will be the area at the bottom? It will be B into L. It will be B into L. Plus C into alpha is 1 into, now instead of 4BL, it will be 2B plus 2L into capital L. Now here instead of L, because we have already designated L as a length of the pile, so here we will consider some different notations. Suppose I will consider this a small L. So this will be the changes. Only these changes you have to made into the equation. Now here, the next one is when there is a layered soil deposit. When there is a layered soil deposit, now the next one, you calculate it. Only change is that there is a, instead of B square, the area is now B into L, and in perimeter it is 4B. 4B it is 2B plus 2L, right? Next numerical, in which the soil are installed in a layered soil deposit, in which the piles is installed in a layered soil deposit. Here, this L1 is given and the another is L2 is given, right? L1 is suppose 4 meter and L2 is 6 meters. L1 is 4 meter and L2 is 6 meter, is the total depth of the pile is 10 meters, right? diameter of pile is given as D is given as 350 mm, 350 mm. When Cu is for the first layer, it is given as 40 kilonewton per meter square. And that for the bottom layer, Cu2 is given as 90 kilonewton per meter square. Abrasion factor alpha over here is taken as 0.5, where alpha 2 is taken as 0.8. So this is the data which is given. Now, only difference is that in this case, when we are determining the load carrying capacity for the tip resistance, we will consider this bottom soil, right? So, only single pile is given, so no need to apply for the second criteria, because we are not considering the group of the pile, so we will use first criteria only. So this is first criteria, in which we will calculate the individual load carrying capacity of a pile. So here this is Q individual is equal to, which we will consider at the bottom, because this soil is at the bottom soil. So Cu2 we will take into consideration. So here this is Cu2 into Nc into pi by 4 d square plus, here we have to calculate twice the value. See, in this case, this plus, it will be Cu1 into alpha 1 into which depth we will take into consideration. It will be N1 plus Cu2 into alpha 2 into L2. Now diving whether the another parameters are same, that is pi into d. So here we will just consider this O into pi and d. That is the only difference that we have to make into the equation, right? Then sometime we just go through it. I think this is clear for you. And the last type of numerical, where you have to find out the diameter of the pipe, or sometimes the length of the pipe or the width of the pipe. In that case, the load coming over the pile is mentioned. In that case, the load coming over the pile is mentioned, and here you have to find out the spacing, right? So in the next class, we will discuss the dynamic formula, load carrying capacity by dynamic formula, that we will discuss in the next class. Okay.